Okay, good morning. We continue with the phenolphthalein. That means color change of phenolphthalein with the pH. Color change of phenolphthalein with pH. Last class we discussed, that means phenolphthalein is pink in color in basic medium. That means when we are adding phenolphthalein to a base, it is pink in color, and phenolphthalein is colorless in acidic medium. What is the reason for this color change of phenolphthalein with pH? That means phenolphthalein is colorless form in below pH 8, that means in acidic medium, and is pink in color above pH 9.5. The reason is that phenolphthalein can exist in two different forms. One is it can exist as colorless benzenoid form in acid medium, and it can exist as a pink colored quinonoid form in basic medium. So phenolphthalein can exist as two different forms. First one is colorless benzenoid form in acid medium, that means below pH 8. Once again, phenolphthalein can exist as in two different forms. One is benzenoid form. Benzenoid form is colorless. When it will exist as a colorless benzenoid form in acid medium, that means below pH 8. Okay, now phenolphthalein can exist as a pink colored quinonoid form. Okay, second form of phenolphthalein is pink colored quinonoid form. When in basic medium, that means above pH 9.5. Okay, pH 9.5. So this is the reason why phenolphthalein is showing a color change between pH range 8 and 9.5. That means below pH 8 means that is of course in acid medium. In acid medium, phenolphthalein will exist as which form? Colorless benzenoid form. But when the pH is changing to 9.5, that means when the solution is changing to alkaline, what will happen? The phenolphthalein will change into its second form. That what is that form? Pink colored quinonoid form. This is the reason why phenolphthalein is showing a color change with change in pH, or why it is showing a color change between the pH range 8 and 9.5. Okay. Now look at here the chemistry of this color change. What is benzenoid form and what is quinonoid form? Let us go through that. And keeping in mind, basically phenolphthalein is a white powder and it is slightly acidic in nature. So phenolphthalein is a white powder and it is acidic in nature. What do you mean by acidic in nature? Of course, phenolphthalein is usually occurring in benzenoid form because it is basically it is acidic in nature. So what is the structure of phenolphthalein? Look at here. Okay, here it is OH, keep it in mind, and here is one bond. Okay, look at here. Okay, here is our C double bond O. Here it is like this, and this bond is joining with another ring. Okay, here it is the second ring. This is phenolphthalein. And since phenolphthalein is naturally acidic in nature, that is why phenolphthalein, you are in the laboratory, you are getting phenolphthalein solution, phenolphthalein indicator, that is a colorless indicator. Phenolphthalein solution is colorless. That means naturally phenolphthalein is acidic in nature, it is colorless. That means this is what is the phenolphthalein which we are pouring, or the liquid phenolphthalein is colorless. That means this is its benzenoid form. It is a benzenoid form of phenolphthalein form and is colorless benzenoid form, colorless benzenoid form. Okay, in acid medium, colorless benzenoid form. Okay, in acid medium and acid medium. Okay, now what is happening? Okay, when we add a base, what will happen? So here this is phenolphthalein in acid medium and it is colorless because in acid medium it is existing as its benzenoid form. Now what we are adding? OH minus base, NaOH. We are adding NaOH, that means Na plus and OH minus. In basic medium, when we are adding, what will happen to the structure of benzenoid form? So when we add a base, what is happening? Look at here. Here you can see that OH means O minus and H plus. Okay. So what will happen? This OH minus, this OH minus removes a proton, that means H plus from OH or from here also, or okay, makes no difference. So keep it in mind. This is a base NaOH. So in basic medium, what is happening? What is the reaction occurring in basic medium, or why the color is changing from colorless to pink color? That chemistry only we are explaining. So phenolphthalein, now phenolphthalein is in acidic medium. In acid medium, it is colorless benzenoid form. To this phenolphthalein what we are adding? We are adding a base. When we are adding a base, what is the chemical reaction occurring? The base, that means OH minus, base OH minus removes a proton from this OH, that means H plus is removed. So what is happening? What we get? We get a structure like this. Okay, here it is. Okay, same structure. We have to repeat a few more times. Okay, here it is C and here it is. Okay, look at it here. Here it is like this. Okay. And here it is C, okay, here it is C double bond O, and here it is oxygen, and here again the second ring, okay, okay, second ring, and here it is our O. H plus is removed, and what is H plus is removed means this bond is here. Look at here, this is OH, this here is a bond. Here is a bond, only that H is removed. Okay, then what will happen to this bond? This bond is shifting to here. Okay, shifting to oxygen. That means this oxygen is getting a negative charge, a pair of electron and a negative charge. Of course, you can see that these double bonds are here. Okay, either it's showing with a ring, and here I required in the form of alternative double and single bond. So I think this step is clear to you. The OH minus removes H plus, okay, and what will be eliminated? Minus H2O. What is eliminated? H2O is eliminated. Okay, then what will happen to this bond, OH bond? This bond is shifting to oxygen. Oxygen is getting a pair of electron and a negative charge. And look at here. Then in the next step, what is happening? This pair of electron is shifting to here. Then what will happen? Here it will become a double bond, correct? Then what will happen? This bond is shifting to here. Okay, that means here it will become a double bond. Then this double bond breaks from this carbon and is shifting to here. Then here it will become a double bond. That time what will happen? This bond breaks from this carbon and it will move to oxygen. Once again, I am repeating. The base removes a proton. So this bond, OH bond is shifting to oxygen. That means oxygen is getting a pair of electron and a negative charge. Now this pair of electron that is shifting to here. A pair of electron means it can make a bond. So here it will become a double bond. Okay, then what will happen to this bond? This bond breaks from this carbon and it will be migrated between these two carbons. So here it will become a double bond. That time this bond breaks from this carbon and it will be shifted to here, and here it will become a double bond. That time this bond breaks from this carbon and it will move to oxygen. So what structure you will get? You are getting a structure like this. Okay, look at it here no change. Okay, look at it here it is OH and here it is C, and here you can see that here, okay, I am writing the second structure like this. Okay, second ring like this. Okay, so when a pair of electron is shifting to here, what will happen? Here it will double bond. Oh, clear? And since this bond is shifting to here it will become a double bond. And since this bond is breaking from this carbon is shifting to here, so what will happen? This will become here it will become a double bond, okay, and this bond is here only, this bond no change, here is, since it is here is a double bond, and here you can see that this bond is joining with, of course, here also no change, here also no change, okay, here C double bond O, no change. Since this bond is breaking from here, what will happen? Here it will become O, and this bond is moving to oxygen. It is getting a pair of electron and a negative charge. Clear? This rearrangement is important. So this is colorless benzenoid form. Okay, that is his acidic medium. Acidic medium. Phenolphthalein is colorless. Okay, now in basic medium, what is happening? The base removes a proton, and there is a rearrangement of bonds, and finally this bond is breaking, and it will change into C double bond O minus. This form is called what is that? Quinonoid form. Quinonoid form, and is pink colored quinonoid form. That means in basic medium, this is in basic medium. In basic medium, what is that? Phenolphthalein existing in what is that? Quinonoid form. Quinonoid form is pink in color. Clear? Okay. Now what will happen? This quinonoid form, now usually in our laboratory what we are doing, we are usually adding phenolphthalein into a base. Okay, in the conical flask we are taking 20 ml of NaOH, we are adding a base. That means immediately what we will get, in basic medium it will change, this is the form, quinonoid form. It will immediately convert into quinonoid form. Okay, quinonoid form. Now what is happening? To this pink colored quinonoid form of phenolphthalein, what we are adding? We are adding acid from the burette. Then what will happen? This acid, so the reverse direction, we are adding acid to this pink colored quinonoid form. That H plus will be taken by this oxygen, then it will become OH, and oxygen is getting a negative charge, the bond breaks. The reverse, in the basic medium, what will happen? The reverse will occur. This is in the acid medium. That means when you add acid, what will happen? H plus, what will happen? The reverse reaction. That means here you can write, okay, this is H plus. When you add H plus, what will happen? The reverse reaction will occur, and what will happen? It will change back to the what is that? Acidic form. When you add acid, finally what will happen? The solution will change into acidic medium. When the solution is in acidic medium, what will happen? The color will become colorless. Pink color will be disappeared. This is the reason how phenolphthalein is showing a color change while we are doing acid-base titration. Acid-base titration. Clear? So if you want, you can start from here, because in laboratory we are starting with the pink colored phenolphthalein. So in pink colored phenolphthalein means what is that? The solution is a basic medium. Of course, we are adding phenolphthalein to a base only. So now what is happening? We are adding acid from the burette. When you are adding acid from the burette, what will happen? The quinonoid form will accept H plus. It will accept H plus, and the reverse reaction and the reverse rearrangement occur, and at a particular point, that means end point, the solution is just changing to acid medium. What will happen to phenolphthalein? Phenolphthalein is just changing to colorless benzenoid form. Clear? Okay. So look at the structure, how the rearrangement. So keep it in mind, this is benzenoid form and this is quinonoid form. Quinonoid form. Now last point. If we add excess of alkali into pink colored quinonoid form. Okay, excess of alkali into pink colored quinonoid form. I told you when the solution is in alkaline medium, what is the color of phenolphthalein? Phenolphthalein is existing as pink colored quinoid form. So this pink colored quinoid form, that means in basic medium, when you add acid, what will happen? It will change back to colorless benzenoid form. Instead of acid, again to this basic medium, we are adding excess of base. That means excess of alkali NaOH. What will happen? It will again change to colorless. It is also will change into color. What is the reason? What is the reason? So follow me correctly. Of course, this you know that this is pink in color. When pink in color, basic medium, okay, pink in color, phenolphthalein is pink in color. When you add acid from the burette, what will happen? Finally, it will change into colorless. That is why it is changing to colorless, because phenolphthalein is changing back to colorless benzenoid form, because this is accepting H plus. When you add acid, H plus is accepting, this bond is breaking, then this bond will go there, this is coming back, and this will again go back. It is changing to benzenoid form when you are adding acid. Instead of acid, again you are adding excess of alkali only. Then also it will change into colorless form. What is the reason? When you add excess of alkali to quinoid form, what is the reaction is happening? So look at here. This is our quinoid form. Once again I am drawing the quinoid form. Okay, here it is like this. Here OH, and here it is our ring like this. Okay, here it is double bond, here also double bond, here is a double bond O, and look at here, I am showing the same quinoid form. Here it is O minus. Okay, to this quinoid form, this is pink color quinoid form, we are adding excess of NaOH, Na plus and OH minus. Then it is changing to colorless. What is the reason for that color change? You can see that this OH minus, okay, this OH minus, okay, will attack on this carbon, okay, then what will happen? Will attack on this carbon, then this will go here, and it will go here, and it will come here, okay, this reverse, and what we get a structure like this. Here it is our OH, and here you can see that this is our C, here it is our second ring. Okay, this is our second ring, and here you can see that since the bond is shifting to here is double bond, and of course our double bond is here, this bond is coming here, okay, and here it is O minus, and what is happening here? Here is our this ring is here, okay, this ring is here, and here you can see that C double bond O, okay, minus, and what is coming here? OH. This OH is attacking here. Okay, so when this OH minus is attacking here, this will go here, this will come here. Okay, now you can see that this Na will come here. So what will happen? This will change into O minus and Na plus, correct? Here also O minus, this also will change into O minus and Na plus, and here you can see that this OH will change into O minus and Na plus. Okay, that means this pink colored, this was quinoid form. Quinoid form is pink colored. This pink colored quinoid form, when you add excess of alkali, excess of base, it will undergo a rearrangement, and what will happen? This quinoid structure is destroyed. The quinoid structure is destroyed, and you can see that it will change into a trisodium salt. 1, 2, 3. Trisodium salt. You get a trisodium salt, and at the same time, what is happening? The quinoid structure is destroyed, and hence it will become colorless. Because when phenolphthalein is a quinoid form, then only it is having a pink color. Okay, when you add excess of alkali, what will happen? That quinoid structure is destroyed. This reaction will occur, that quinoid structure is destroyed, and this quinoid structure is changed into a trisodium salt. That trisodium salt will not have the pink color. Clear? So once again, look at the reaction or the acid-base titration. You are think about the acid-base titration you are doing in the lab. We are taking, suppose we are taking 20 ml of NaOH in a conical flask. When you add phenolphthalein, it is pink in color, because in basic medium the phenolphthalein will be in the quinonoid form. So that is why it is pink in color. Then when you add acid from the burette, what will happen? That OH here is a OH in the quinonoid form. That OH O minus will, this O will take H plus from the acid, So what will happen? The bond will break, and what will happen? It will change back to the benzenoid form. That when it is changed into benzenoid form, that is what is the end point. Because the quinonoid form is accepting H plus, accepting, and finally what will happen? It will change into benzenoid form. That is color change. That is the end point. That means the alkaline solution is just changed into acidic medium. This is the theory of color change of phenolphthalein. Now there is an extension. If we are adding excess of alkali into the same quinonoid form, pink colored quinonoid form, we are adding the base only. So what will happen? Then also it will change into colorless. What is the reason? When you add excess of base, what will happen? This reaction will occur, and the quinonoid structure is destroyed, and we get a trisodium salt. Okay. That's all about phenolphthalein, and thank you.